All right, we're in section 4.6 where we are going to talk about negative and zero exponents. There are some rules for both negative and zero exponents, and for zero exponents, it's fairly simple. If you have any non-zero number, like a, so we'll just denote it as a variable a, so any number that's raised to the 0 power will always be 1. So if I had 2 to the 0 power, that would equal 1. If I had negative 5 to the 0 power, that would equal 1. If I had 1,000 to the 0 power, that would equal 1. So any number raised to the 0 power will equal 1. Now, the rule for negative exponents is read like this. So if you have any non-zero number, we're going to call it a, and any integer n, so we're going to say if we have a raised to the negative n power, in order to make my exponent a positive number, I must have it 1 over a to the n. So if our value is a negative number in the numerator, it'll be positive in the denominator. Okay? So taking a look at these examples here, what I want to do is get my exponents to be positive. So for this one here, using the rule of negative exponents, I have a negative 2. In order to make that a positive 2, I must raise it, put it 1 over 5 squared. Okay? Looking at the second example, I have 3y to the negative 2 power. That negative 2 raised power is only attached to y. So I got 3 times 1 over y squared, and when I multiply across, it'll just be 3y squared. Looking at the last example on this page, I have a to the negative 7 power multiplied by b to the third power. A has a negative exponent, so I have to make it to 1 over a to the 7th, multiply it by, b is already a positive exponent of 3, so I'm going to leave that in the numerator. So when I multiply this across, it's going to be b to the third over a to the 7th. Okay? So if we take a look at this chart here, I have values of positive and negative exponents. So if I look at, say, let's just look at the chart with 2. I have 2 to the third power. 2 to the third power means 2 times 2 times 2, which gives me 8. 2 squared is 2 times 2, which gives me 4. 2 to the first power gives me just 2. 2 to the 0 power, remember, is our rule, is always going to be 1. And 2 to the negative 1 power means that this become, I bring this this 1 over 2 to the first power, which makes it a 1/2. So 2 to the negative 1/2 power gives me 1/2. Looking at 3, 3 to the third power is 27. 3 squared is 9. 3 to the first power is 3. 3 to the 0 power will be 1. And 3 to the negative 1 power is going to be 1 over 3, because we're going to make it, when we make it positive, is we're going to bring the exponent down to the denominator. So following that pattern, let's take a look at 2 to the negative 2 power and 3 to the negative 2 power. So if I have 2 to the negative 2 power, by rule, it's going to be 1 over 2 squared, which means that 2 to the negative 2 power is actually 1/4. And 3 to the negative 2 power, using the rule, it's going to be 1 over 3 squared, which equals 1 over 9. So this section here is going to kind of show us a little bit in reverse of what we just did. What I want to do for these expressions is I want to be able to remove the fraction bar. How we do that is we just take values and put them as negative exponents, just like this first one here of 1 over 16. I know that 16 is 4 squared, so that's why it's equaled 1 over 4 squared. And in order to remove that fraction bar, I just remove my 4 squared to the numerator and make my exponent a negative number. Similar to 2 over a to the 8th power, that's going to equal 2a to the negative 8. So if I look at this example here, I have 1 over 1,000. I can write it like this. So I have 1 over 1,000. Another way to write 1,000 would be 1 over 10 to the 3rd power. Then if I want to remove the fraction bar, I take my 10 to the 3rd power, put it in the numerator, and attach a negative exponent to it. Same thing goes for this example. I got x to the 7th and z over z to the 2nd. My x to the 7th is already positive, so I can leave it as is, and it's going to be multiplied by z, but it's going to be to the negative 2 power. So I removed my fraction bar for those particular problems. Looking at these ones have different set of parameters. Let's take a look at the first one. I have 17 a to the 3rd divided by a to the 7th. Okay? Remember our rules. So these have the same base. You are dividing them. So we're going to be using the quotient property of exponents. So I can say 17 and then go a to the 3 minus 7 power, which then it's going to equal 17a to the negative 4 power. And if I wanted to remove the negative exponent, it would just be 17a to the 4th. Okay? Same thing goes for this one here. 15 divided by 3 will give me 5. I have b as the same base. So again, I'm going to be using the quotient property. So it's b to the negative 5 minus 4, which brings me to 5b to the negative 9th. And if I want to remove that negative exponent, it would be 5 over b to the 9th. The next one here is 15t to the 3rd multiplied by 3t to the negative 8. So I'm going to multiply these two values together, which gives me 15. And then I got t, and I'm multiplying by the same base, so I have to add the exponent. So now it becomes 3 plus a negative 8. This is 15t to the negative 5. And if I want to remove the negative to my exponent, I will just bring it down to the denominator. This one here, I got 4 times 7, which gives me 28. A to the 0 power is just 1, so I'm just left with a to the negative 4th power. And if I wanted to bring it down into as a positive, it would be 28 over a to the 4th. I'll do one more. Let's take a look at this one. So let's say we have a to the 6th, b to the 4th, divided by a to the 3rd, b to the 7th. Well, here I have two values with the same base. So I got a, and I can use the quotient property by subtracting the exponents 6 minus 3. And then I got b, where I can subtract these exponents of 4 minus 7. So now this is going to equal a to the 3rd power and b to the negative 3rd power. And if I were to want to make all my exponents positive, the result would be a to the 3rd over b to the 3rd. And that is being able to use the rules for negative and zero exponents. Hope this helps. Until next time.